All right, so now what we're going to talk about is we're going to talk about infinite limits. So this is going to give us our third piece of an intuitive way of thinking about limits. So let's suppose that I have the limit as x approaches 1 of 1 over x minus 1, okay? And so what I want to know is what happens to this function as x approaches 1, okay? Now if we notice, if I plug it in, f of 1 is going to equal 1 over 1 minus 1, which is 1 over 0, and that does not exist. All right, that's problematic, and that's not going to exist in algebra. We'd say, you know what, doesn't exist. I'm not gonna even worry about it. Okay, but what we want to do in calculus, we actually want to like understand what the behavior of the function is as we get closer and closer and closer to 1. Okay, so let's actually first start out. Let's see what's the limit as x approaches 1, and we'll do it now from the negative side. We're going to look at limit as x approaches 1 of 1 over x minus 1. And what we're going to do is we're going to first look at it from the left-hand side. So I'm going to draw a table in order to do this. And on the one hand, I'm going to have x, and then I'm going to have x minus 1, and then I'll have f of x, right? What happens to f of x? And I'll start out at 0, and then I'll go to 0.5, and then 0.75. So we're going to get closer and closer from the negative side to 1 over x minus 1. And then 0.9, 0.99, 0.999, and then 0.9999. Okay? So x minus 1 here is going to then be negative 1. This will be negative 0.5. Okay? This will be negative 0.25. Okay? And then this will be negative 0.1. This will be negative 0.01, negative 0.001, negative 0.0001. Okay, so notice that as I get closer and closer to 1, my x minus 1s are going to get smaller and smaller, right? Just like my x's. That's what should happen, all right? And we're going to get really close to this being 0, because that's the idea, right? We're getting it close to 0, but not hit it. Okay? But what happens to 1 over x minus 1 then? Well, for this one here, for 0, it's just negative 1. But then for 0.5, it's now 1 over negative 0.5, so that's negative 2. 1 over negative 0.25, and you should use your calculator to actually go in and do this. This is a great opportunity to get some number sense, is negative 4. Then we go to negative 10, then negative 100, then negative 1,000, and then negative 10,000. So notice what's happening here with 1 over x minus 1 is as I get closer and closer and closer, right, okay, as the limit as x approaches 1 negative, right, gets closer to 1, okay, as we get closer to 1, what we end up getting is we end up getting a number that gets closer and closer and closer to what we're going to call negative infinity, right, okay. This is getting larger in the negative direction. So it's going down towards what we would call negative infinity. Now let's take a look if we did it on the other side. Okay, what happens as we approach x, as we approach 1 from the positive side? Here now, limit as x approaches 1 from the positive side. Okay, we have x minus 1, we have f of x. All right, okay. We'll do this, we'll make this one 2, and then we'll have 1.5, 1.25, 1.1, 1.01, 1.001, and 1.0001. Okay? This will be 1. Okay? And then f of x is going to be 1. This will be 0.5. Now f of x is going to be 2. 0.25, f of x will be 4. 0.1, f of x will be 10. 0.01, 100. 0.001, 1,000. 0.0001, 10,000. And so what we notice here is as x approaches 1, and I'm going to write that as my shorthand, as x approaches 1, then f of x gets larger in the positive direction. Now, the question is as I get really close to 1, this value here is going to get smaller and smaller and smaller. So x minus 1 gets smaller, right? And f of x thus is going to get bigger. Because what we have is, if you remember from algebra, we have inverse variation, right? We've got it to where as x minus 1 gets smaller, f of x is going to get bigger. They're going to go in the opposite directions, right? But we have some sign. We have a sign involved here, right? A negative versus a positive. So we say here, what we're going to do, the limit as x approaches 1 from the positive direction of f of x is going to equal positive infinity. And we don't put a sign on that one. And the limit as x approaches 1 from the negative side is going to equal of f of x is going to equal negative infinity. Because it's getting everlastingly smaller. Smaller and smaller, 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 smaller. Okay? Whereas the other side is going to get bigger and bigger and bigger and bigger. Now let's consider the limit of cotangent. So the limit as x approaches 0 of cotangent of x. Now this is going to equal the limit as x approaches 0 of sine or cosine over sine. So as x approaches 0, sine of x is going to go to 0. So cotangent of x, right, or cotangent of 0, excuse me, is undefined, right? Basically have that idea. Yeah. There you go. Okay. Now, let's take a look and we're going to say, okay, well, let's imagine the limit, and let's draw a picture. We'll draw a picture of cotangent. Okay. Here's pi over 2. Here's pi, okay, and here's 0. So this is the value that we want. Now, if you remember, right, it's going to be positive up here. Cotangent is going to be positive. Then it'll go 0 at pi over 2, okay, and then we're going to go down towards negative infinity, okay. On the other side, right, we're basically going to get something that looks like this. Yes, because we just cycle, right? So the limit as x approaches 0 from the positive side, or from the negative side of cotangent x, is going to equal negative infinity. Whereas the limit as x approaches 0 from the positive side of cotangent x is going to equal positive infinity, right? As we go up this way in the positive direction, we end up with positive infinity. As we go in the negative direction, cotangent of x goes down to negative infinity, okay? At x equals 0, f of x has, and this should be a reminder from your calculus class, has a vertical asymptote. If we have, right, if we have a function where the limit at L approaches infinity, approaches infinity from the right or the left, we have an asymptote. A vertical asymptote, excuse me. That actually brings us, why don't I give you a second to write that down? So cotangent x is an example of one where we have a vertical asymptote. The fact is that the limit 1 over x minus 1 also has a vertical asymptote, okay? Right? On one side of it, it's going to go down to negative infinity. On the other side, it's going to positive infinity. Sometimes we'll actually get them to agree, right? Like, for example, 1 over x squared, which will be in your reading. What you'll see there is you'll actually see that, in fact, its limit as we approach 0 is going to equal positive infinity, whether or not you come from the right or the left. Okay? And we've got one more, and this one's really important. Okay? This is the natural log of x. The limit as x approaches 0 positive, the natural log of x is equal to negative infinity. So what we have there is we have a vertical asymptote at negative infinity. Now, natural log of x is undefined at 0, and it's also undefined for anything less than 0. But it does have a limit, theoretically, as x approaches 0 positive, and that's negative infinity. So take a look, right? As x approaches 0 from the positive side, we end up getting negative infinity. And that's the limit of the natural log of x. So what we're going to do is we're going to add in, we're going to say, okay, well, let's define, or let's allow ourselves to define limits if we can't exactly say what number they are, but they keep increasing without end. And in fact, we're going to define this more precisely later on. If they keep on increasing without end, then what we're going to say is that they have a limit of positive infinity. Also, if they keep on decreasing without end, then we're going to say that they have a limit of negative infinity. Okay? So this completes the lesson on limits at infinity.